Hi students. Okay, so welcome you all for the today's class, and we were doing indefinite integrals. Okay. Hi students. And we have also covered our exercise 7.1, and today I am going to continue with the problems of, or not problems, I am going to continue with the next concept of indefinite integrals. Clear? Because we have already completed exercise 7.1, so now we have to go for the next concept. And in the 7.1 exercise we have just covered the formulas, the basic integration, and the things what we need uh, as a basics for integration we have learned in the exercise 7.1, and also we have gone through all the formulas that we required to start our integration. Okay, so today I am going to start the very important concept, that is methods of integration. Okay, so this is going to be very important because you must know what are the methods of integration and how to apply the methods whenever you are solving the integration problems. Because in any exam or in any competitive exam they directly give you to solve the problem. They don't tell solve it by substitution method, solve it by partial fractions, and like that they are not going to tell, or solve it by parts they are not going to tell. They will give one problem and they will ask you to simplify it. Okay, so if they give the problem, you must be in the position that you have to understand, is it from substitution, or is it from partial fractions, or it is from integration by parts. Okay, so these are the three methods that we are going to apply for our integration. Okay, so whenever you see the problem, first you have to check the particular problem is going to be solved by which particular method. Okay, whenever you see the integration problem, you have to identify the method which you have to apply for that particular problem. Is it from substitution, is it from partial fractions, or is it from by parts? Okay, sometimes a single problem needs all three methods. Okay, or it may need first method and second method, or it may need only one of this. Clear? So that's why you have to be perfect with all three methods. Clear? See, here only very important thing is, in some problem I take one. In problem 1 you may use substitution, in problem 2 you may use partial fraction, in problem 3 you may use by parts. Okay, so there will be some problems which are like very interesting. For example, I will take problem number 10. In this problem number 10, what happens? All these three methods you have to use to simplify this problem number 10. Clear? Because that problem will be framed in that such way. Okay, so these all three methods are going to be needed to solve this problem number 10. Either for example, problem number 1 is going to be solved by only substitution, no problem. Problem number 2 is going to be solved by only partial fractions, no problem. And in problem number 3 it is going to be solved only with pi parts. But there are such type of problems where you may use all three methods in a single problem. Okay, so that's why what I say, integration is just about, first thing is formulas, and next thing is your skills on using this particular methods. Okay, how much fast and quick you are going to be in this three methods, and how much beautifully you can understand these three methods, such easily you can move in your integration. Okay, So that's why these three methods are going to be very, very important. So please go through these methods, understand these methods, and try to solve the problem. Okay. So first we shall go one by one. First I will solve by substitution. Next I will go for partial fractions, and next I will go for by parts. Okay. So one by one I will be solving, but please remember all three methods are very, very important, because integration can be solved in using all these three methods. Clear? You can use any method of these three. There is no rule that you have to solve with only three. There is no rule that you have to solve it by only first method. There is no rule that you have to solve it by second method. You can solve it by whichever method in which you are perfect. Okay. So that's why you keep it in mind, and please practice all three methods. Understand all three methods, when to use this particular method, that you have to be very much perfect. Okay. So today I will go with substitution and some examples, and tomorrow or day after tomorrow I will go with partial fractions, and after the completion of partial fractions I will go with by parts. Okay. Don't miss any classes, watch in the sequence. Okay. If you want to solve tomorrow's problem, the previous video which I have solved yesterday is going to be very, very important. If you want to understand today's class, you must be perfect with yesterday's class. If you want to be perfect in tomorrow's class, you have to be perfect in today's class. Okay. So that's why it is going to play very, very important role. So please concentrate on the methods of integration, and you just understand them. Don't by heart anything. Okay. You understand the methods, you understand the tricks, or you understand the techniques of the problem where to apply. Okay. So first we shall start with substitution method, and second method is going to be partial fractions. Third method is going to be by parts. Okay. So first we shall see substitution method, that is integration by substitution. So this is our first method, and in this you just see here the given integral, integration of f of x dx. That means they are going to give you some problem like you solve the integration of f of x dx. Okay. So they will give solve integration of f of x dx. So it can be any real function. So f of x is any real function. Please understand, it is any real function that you have studied in your 11th class. Okay. So there are so many type of functions: mod function, trigonometric function, polynomial function, or signum function, any special type of functions. Clear? So there are so many number of real functions. In that it will be any one of that real functions. Okay. So they will give you to solve this particular integration. So here what you have to do, you have to just watch this integration and you just see what they say. So integration of f of x dx can be transformed into another form by changing the independent variable x. That means, see this variable x, this is called, x is called independent variable. Okay. So this independent variable can be changed to another word, that is t. So this x is going to be changed for t. That means they are substituting x is equal to like g of t. They are going to substitute x is equal to g of t. Okay. So now what happens for this particular function? In the place of x, you are going to get g of t. In the place of x, you are going to get g of t. So see this, what will happen in the next step? Okay, see here. What they are going to put? They are going to put x equal to g of t. That means in the place of x, they will put g of t. So if I differentiate this, if I differentiate x is equal to g of t. So if I differentiate x with respect to t, what it will happen? Dx by dt. will be equal to g dash of t. Okay, so here the variable is t, so that's why I have to differentiate this x equal to g of t with respect to t. Okay, so if I differentiate this x with respect to t, it will be dx by dt, and this g of t will become g dash of t, g dash of t. Okay, so in the place of x, now you just see, in the place of x you will write g of t, in the place of x you will write g of t, and in the place of dx, in the place of dx you just see, it will become g dash of t into dt. So in the place of dx they will write g dash of t into dt. Okay, so now you have to solve this. Clear? Please understand this, very very important. See, first thing they will give you to solve I equal to integration of f of x is equal to dx. So now I will see this function according to my particular thing. Now I want to apply substitution method. If I want to apply substitution method, what I have to do, in the place of x, in the place of x I will put g of t. So what it will happen, f of g of t. Okay, so in the place of x I have written g of t. So now dx also has to be changed. How to change this dx? You just see this, you differentiate this particular function. So if I differentiate x with respect to t, it will become dx by dt, and this will become g dash of t. Okay, so dx will be equal to what, g dash of t into dt. Okay, so therefore in the place of dx you have to write g dash of t into dt. Okay, now you have to solve this. Now you have to solve this. Okay, say this, integration of g of t multiplied with z dash of t into dt. Okay, so quickly reply me with your chat box that have you understood this theory or not. Please reply me. Please reply me, have you understood this steps or not? Very very important. That means how to use substitution method. I am telling how to use substitution method. Okay, and what is there in the substitution method, that we have to understand. In the substitution method, two things are very very important. What are those two things? One is x, another one is dx. In the place of x we write g of t, and in the place of dx we write g dash of t into dt. So if you want to write g dash of t into dt, you just say x is equal to g of t, that you have to differentiate. So it will become dx by dt equal to g dash of t. So dx is going to be equal to g dash of t into dt. Okay, so this you have to write in the place of dx, and you have to solve your integration, Okay, quickly tell me everyone, all has to reply. Okay, so now I will go for some simple examples. Okay, so you just see example 1, that is I have to integrate sine of mx. So see here what they are asking, to integrate sine of mx with respect to dx. Okay, here what they will tell, integrate. Here they will give you integrate. The first example is sine of mx. So now I have to solve integration of sine of mx with respect to dx. So just my dear students, you just see here what I will do. I will put mx as t. Okay, so now if I differentiate it with respect to dt, here you have m, you write as it is. If I differentiate x with respect to t, it will be dx by dt, and differentiation of t with respect to t is 1. Okay, differentiation of t with respect to t is 1. Now what it will happen, dx will be equal to dt multiplied with 1 will be dt, and if m comes on this side, it will be divided by m. Okay, so now you just see here, mx becomes t, mx becomes t, dx becomes dt by m. So very important, and this is also very important. Okay, now you have to replace the terms. Integration of sine of mx, you are writing it as t, and dx you are writing it as dt divided by m. Clear? So now you just say what is integration of sine, that is minus cos t, and divided by m is constant, right as it is, plus c. Okay, so now minus cos of what is t, see here, t is mx divided by m plus c. Okay, now this is your answer, that is integration of sine mx with respect to dx is equal to minus cos of mx divided by m plus c. Clear? So anyways, directly by using the formulas, we know that integration of sin x dx is equal to minus cos x plus c, and we also know that integration of sin of ax with respect to dx is minus cos of ax divided by a plus c. So these formulas we already know, but I want to explain you substitution method and the steps of substitution method. So that's why I am explaining all these terms. Okay, to make you to understand how to solve with substitution method, I am explaining all these things. Clear? But if you get any this type of problem, directly you remember these formulas. Okay, so coefficient of x has to be divided in the integration, that you have to do. I think you have understood this. Clear? So you just say they have given sin mx dx. They have given sin mx dx. Okay, I will replace mx as t. I will replace mx as t. Once you do substitution, the substitution has to be differentiated. That means the term which you have substituted, that has to be differentiated. So you differentiate it. What it will be? M into dx by dt equal to 1. Okay. So you multiply dt to LHS. So that will be 1 into dt dt. And you take this m on LHS, it will be dt by m. Okay. So now here what you are substituting mx as t. This is your substitution. So if you do this substitution, dx will change to what? Dt by m. Okay. So mx will change to t, and dx will change to dt by m. So change all those terms, and now you do the integration. This is all your substitution. Okay, this is all your substitution steps. After doing substitution steps, you have to do integration. So what is integration of sin t? Minus cos t divided by m is constant, right as it is, plus c. Now what is t? Mx. You replace that. Okay. So if you do this, your problem is over. Okay. Quickly tell me everyone, have you understood this? Already I have explained twice. So please quickly tell me, have you understood this? Okay. So now I will go for the next particular problem, so that again you can understand this type of things. Now you see the second problem. So now you see the second problem. So they are telling you to integrate 2x sine x square plus 1. So here you just say, here I have x square plus 1. So here I will give you one trick. If you want to identify substitution method, you just see this function, and you search for t equal to, okay. So here t equal to, I will take x square plus 1. Why? Because see, I will put t equal to x square plus 1. Why I will put t equal to x square plus 1? Because you just see here, after substitution we have to differentiate this, okay. So if I differentiate this with respect to t, what I am going to get, that is important. So if I differentiate it with respect to t, what I am going to get, you just see it. Differentiation of t with respect to t is 1. Differentiation of x square is what? 2x into dx by dt, because you are differentiating with respect to t, and differentiation of 1 is 0. So now if I simplify this, it will be t into dt equal to 2x into dx, okay. So why I put t equal to x square plus 1? Because if I differentiate this, I will get 2x, which is already present in the problem. See, if I put t equal to x square plus 1, I will get 2x, which is already present here. So that is the trick for me to do the substitution, okay. That is one small trick that you can identify. So using that trick, easily you can identify what to substitute. Easily by this particular trick, you can understand what to substitute, okay. Because there is a question, why should I write t equal to x square plus 1, okay. Why I can't write t equal to another function? See, why should I write t equal to x square plus 1? Because if I write t equal to x square plus 1, I know that has to differentiate. Whatever you are going to write for t, that you have to differentiate. So once I differentiate it, it will become t equal to 2x. Because differentiation of t with respect to t is 1. Differentiation of t with respect to t is 1. Differentiation of x square is what? 2x. So you see that 2x is already present here. So therefore, I should substitute t equal to x square plus 1. In the previous problem also I will say. In the first problem also you see, I have substituted t equal to mx. Why? Because if I differentiate this, differentiation of t will become 1 and I will get dx by dt. So dx term is already present here. So I will get dx. Okay. So that's why I will put mx equal to t. Clear? On the same way, here I am going to put x square plus 1 as t. Because if I differentiate it, differentiation of t will be 1 and differentiation of x square is 2x. It is going to help us to replace 2x into dx. Okay. So you just see here, 2x into dx will become dt. Sin of x square plus 1. X square plus 1 will become t. Now you please see this. Very, very important. See here. Integration of sin of x square plus 1. This 2x I will write here, 2x into dx. So now this will be equal to see here, 2x dx will be t dt, sorry, not t dt, only dt, not t dt, only dt, okay. Because here differentiation of t is 1, 1 into dt is dt. It will become only dt and x square plus 1 will become t. So therefore, sin of t into dt. If I replace 2x dx as dt, and x square plus 1 as t, it will be sin of t dt. So now if I integrate sin t, I know that it will be minus cos t. I know that it will be minus cos t plus c. So now minus cos of what is t, that is x square plus 1 plus c. In the place of t I will write x square plus 1. Okay. So therefore cos of x square plus 1 plus c will be the answer. Cos of x square plus 1 plus c will be your answer. Clear? All of you quickly tell me, are you following my particular steps? Are you following my particular steps? Are you getting my tricks of integration? Okay. So now quickly tell me yes or no. And in the third problem, what I have to put for t, you have to tell. So here integration of tan raised to 4 root x secant square root x divided by root x with respect to dx. So quickly tell me for t equal to what I have to write. I have to substitute for t. So for t what I have to write? You have tan raised to 4 secant square and also root x. Okay. So you have these functions. Now tell me what I have to write for t. Quickly think and tell me the answer. Quickly think and tell me the answer. What should I write for t? So here I must write one function. After differentiating that function, the same thing has to be present here. Very good. Very good. So t must be equal to tan root x. T must be equal to tan root x. Not only root x, tan root x. Because you just see, if I differentiate this, what I am going to get? Suppose if I differentiate this with respect to x, I am going to get dt by dx is equal to, what is differentiation of tan? Secant squared root x. And what is differentiation of root x? Differentiation of root x is 1 by 2 root x. Okay. So please say this. I will put tan root x as t because if I differentiate tan, I will get secant square root x, which is already present here. Clear? So which is already present here, and also the differentiation of root x is 1 by 2 root x. So now what it will be? I will take 2 on this side. So 2 times of dt divided by dx will be equal to secant squared root x divided by root x, and 2 dt, I will take dx on this side, it will be secant squared root x divided by root x will be equal to dx. Okay. So now you just replace all the terms. So tan raised to 4. So tan root x will become t. So t raised to 4 secant square root x dx by root x will be 2 times of dt. Okay. So now if I integrate this, 2 is constant, t raised to 4 will be t raised to 5 divided by 5 plus c. So therefore 2 divided by 5, t is what? Tan to the power of 5 root x plus c. So all of you quickly reply me, have you understood this? All of you quickly reply me, have you understood this? You have to put t equal to tan root x, because if I differentiate tan, I will get secant square. I am differentiating with respect to x, not with t. So dt by dx will be equal to secant square root x multiplied with 1 by 2 root x. So therefore I will take 2 on LHS, it will be 2 dt divided by dx equal to secant square root x divided by root x. I will take dx on LHS. It will become 2 dt equal to secant square root x divided by root x dx. Okay. So now I will replace all the terms. Once I replace all the terms, it will be t raised to 4 dt. Clear? So very important thing is what you have to put. So in the last step, you just see, you will get t raised to 4. So integration of t raised to 4 is t raised to 5 divided by 5. What is t? T is tan root x. That you have to write here. In the last step, you have to again write what is t. What is t? Tan root x. That you have to write here. Okay. So in the first step, very important thing is what is t. Once you get t, you differentiate that. Once you differentiate that, you replace all the terms. After replacing all the terms, you must do integration. Once you do integration, your problem is over. So here you just see, first thing, search for t. Second thing, differentiate for t. That means nothing but dt by dx. And third one, replace all the terms. And fourth one, solve it. Okay. So see here, in the first step, you have searched for t. In the second step, you have differentiated with respect to x. In the third step, you have replaced the terms. This is your third step. You have replaced the terms. And this is last step. Solve it. Integration of t raised to 4. Okay. So this is how you have to solve your integration problems of substitution method. So now, this is the fourth problem. So quickly tell me, all of you, what I have to write for t. In the integration of sine of tan inverse x divided by 1 plus x square with respect to dx, t equal to, put t equal to dash. Quickly tell me. Put t equal to dash. If you tell that, today's class is over, so I will continue from tomorrow. Quickly tell me what is t. Very good, correct. So t is equal to tan inverse x. T is equal to tan inverse x. Clear? So now you just solve it and try to get the answer. Tomorrow I will continue with this fourth problem. Okay. So tomorrow I will continue with this fourth problem. You solve it and you just keep it ready. Clear? And again assignment, continue for 3 times. Today's problems. I have solved only 3 problems. So you write those 3 problems for 3 times. That is today's assignment. Clear? So therefore you complete the 4th problem. You write complete the 4th problem for 1 time. No problem. Clear? Okay. So thank you everyone, and we shall meet in the tomorrow's session and we shall continue the problems. Take care.